Last time I promised you a video where I construct the RibThread tool by hand, and here it is. I tried a couple experiments before settling on this construction of the tool. This will be done entirely in the part workbench in the stable version of FreeCAD. No additional modules will be required. Before starting, click on the macro record button. This will keep a complete transcript of everything that happens on the console. In a future video, I'll take that transcript and turn it into a macro that produces the tool for us. I'll just name it TestRT since I actually already have the macro I need and don't want to overwrite it. The red circle turning into the green square lets us know it's recording. Since there are a number of parameters to the RibThread tool spread over several different components, we'll need a VarSet to bring it all together. First, height. Put that in a group called dimensions. Since height implicitly needs a unit, rather than have it be a property integer type, use the property distance type. Set a default value of 10. Check the Add Another box so that we can just enter rapid fire. Next is diameter. Same group, same type, value 5. Then drill diameter, 4.5. Now bore depth, 1. Finally count. Since it makes no sense for the count to be in millimeters, set its type to property integer. That's the last property, so uncheck the Add Another box. Select the VarSet, and in the data pane we can see all of our dimensions. A VarSet is really just a feature that doesn't have a shape. Rename the VarSet to just V to make it easier to type since we'll be using it a lot. This tool is designed entirely using primitives and thinking about negative and positive shapes. In fact, the final tool will be a negative shape since it's meant to be cut from another shape to make a hole. Start with the cylinder. Select the cylinder and in the data pane set the radius to v.diameter divided by 2. Set the height to v.height. Create a second cylinder. Set its radius to v.diameter minus v.drill diameter divided by 2. The height will be v.height minus v.bore depth. Now to move it into place. Select Cylinder 001 and go to Part Attachment. Select the bottom edge of the large cylinder. We want one of the Frenet modes for the attachment. Trying them out, we want Frenet T and B. Now select Cylinder 001 again and draft Polar Array. Since the dialog doesn't allow entering formulas, set count to 3 for now. Be sure to hit reset so that the polar axis will be the z-axis. Hit OK. Select the array and in the data pane under number, set a formula v.count. Based on that showing the value of 0, I realize I forgot to set the count in the VarSet. So select v and set the count to 3. That's more like it. The array represents the ribs that we're going to want in the final tool. But they need to be beveled at the top in order to guide the eventual bolt into place and allow it to begin cutting threads. So add a primitive cone. In the data pane, set radius 2 to v.diameter. Radius 1 should be 0. I want the cone to create a 45-degree bevel in the tops of the cylinders, so the height of the cone should be equal to its radius 2. If you picture a right triangle that revolves to form a cone, it'll become obvious why that's the case. Looking at the cone in relation to the rest of the shape, I see I've made an error. Radius 2 should be v.diameter divided by 2. That's more like it. Now to put the cone into position. Set a formula for placement.position.z. Cylinder 1 .height minus radius 2. That looks about right. Select the array and the cone and cut. Now select the cylinder and the cut and cut again. That's our tool shape. I'll go ahead and press G and R to get rid of the draft plane. Since we have our shape, click on the green square to stop recording the console now. In a future video, I'll turn that transcript into a macro to create the tool shape. As you can see, I can just change parameters within the VarSet to parametrically change the shape. Note that reducing the drill diameter increases the size of the ribs. Of course, the diameter must always be larger than the drill diameter in order to have a valid shape. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.